Assalamualaikum everyone. Welcome back to mathematics, and I'm introducing to you a new series which we will be uploading now, and that is we will be uploading the topic wise explanation of Pearson EDEXCEL A levels, because I have got a lot of requests from my students that we don't have much resource available online for Pearson EDEXCEL. So we will be uploading all the topics. We are starting from Pure Maths 1. After completing Pure Maths 1, we will move on to Pure Maths 2, and then 3, and then 4. We will be covering all of the Pure Maths, and hopefully after completing that also stats and mechanics. So we will be proceeding with the book. Also we'll look into your syllabus. Obviously your book is according to that, but I will be following your chapter wise distribution for Pure Maths 1 EDEXCEL book. So today let's begin with chapter 1, Algebraic Expressions, in which we have subtopics, index laws, expanding brackets, factorizing, negative and fractional indices, surds, and rationalizing denominators. So let's begin. Starting off with index laws, I will be combining these two topics, index laws and negative and fractional indices, because these two can be covered side by side because they are interlinked. Okay, so let's begin with that. Okay, what are index laws? Whenever we come across numbers or variables with some powers and they are multiplied or divided, so their powers have to be dealt in a different way. Either their powers add up or get subtracted or multiplied. So how did this happen? What is the rule? What are the rules of it? We will be discussing that. Okay, I have mentioned some rules in front of you. Now let's see, if two numbers or two variables are multiplied and they have some different powers, m and n represents different powers. So if you have same base, so first I'll write here a represents your base. Okay, base means for which you have the subscript power. So a is your base, m is your power. So we haven't used just a, we also have used a or b. So a and b represents your base, and m and n represents power in these laws. Now what happens when we multiply your two numbers or two variables that have different powers? See, m and n means that they are different powers. That is why we have used different letters for it, and a represents that we have common base. So whenever this is the case, what happens is we write the base once and their powers add up. So you will write it as am plus n. Okay, I will give you an example for each one of them. Example for this is, for example, if you have x to the power 2 multiplied by x to the power 3, so it will give you x to the power 2 plus 3, that is x to the power 5. Then for example, if you can have base also as a number, so if you have 2 to the power 1 multiplied by 2 to the power 4, then their powers, again the base is same, you will write once and you will add the powers as 2 power 1 plus 5, that is 2 to the power 5. Now let's talk about the second law, that is, if your two numbers are, in the second law, if your two numbers, two variables, two bases are divided, that is, that are having the same base but different powers, and they are divided, you are going to subtract their powers. You will write your base to be ones, that is common, and you will subtract their powers, m minus n. Okay, so let's take example for this as well. For example, you have x to the power 3 divided by x to the power 2, so you end up getting x to the power 3 minus 2, that is 1. So we often don't write the power 1, so it is this. Now let me show you. If you have like 2 over 2 to the power 4 and 2 to the power 6, or let's take the smaller number, if it is written in division like this, then it will be equals to, you will write the base ones and then subtract their powers, you will end up getting 2 to the power 1, that is 2. So this is how the powers behave when they are of same base and their bases are divided. Now let's talk about if you have a power with a base and it has some whole power also. So what happens is their powers multiply. Power of a power gets multiplied. Okay, so let's rearrange this a bit, and now what happens is you will end up getting a to the power m times n or a to the power mn, because when we write the variables, we don't put a multiplication sign in between, we can just write it as it is side by side, that shows it is multiplication. Okay, so m times n. Let me give you an example. For example, if you have 2 to the power, it is 2 square whole power cube, that means 2 to the power 2 times 3, that gives you 2 to the power 6. Or let's take x to the power 3 whole power 4, that gives you x to the power 3 multiplied by 4, that gives you x to the power 12. I hope you get this example too. Moving on to next law of index, that says if you have different bases, now a and b represent some different numbers which are multiplied or variables that are multiplied but having the same base. M and m represents that they have same base. So in such case, what can we do is you can multiply these numbers or variables and you can write their power as one whole. Okay, if they have a common power, you can write it as a common power. For example, if you have 2 to the power 3 multiplied by 4 to the power 3. Okay, so you have same power, so you can write it as 2 multiplied by 4 whole power 3. Similarly, if you have a variable, for example, x squared times y square, power should be same. Bases could be different, bases are different. So what you can do, you can take it as a whole power. X times y whole square. Okay, the opposite of it is also true. This also applies vice versa. Means if you have two numbers or two variables that have some power m, then the power will be distributed on your a and on your b also. So you will again get a to the power m times b to the power m. So I want to rewrite it, because this is the same rule that applies both ways. So let's write this down, that if you have a times b whole power m, that also means that you can write it as a to the power m times b to the power m. The power got distributed. Okay. Now let's talk about one more law of index, and that is, if you have two bases that are different, a and b represents different bases, and you have same power, so you can write it as a divided by b and whole power a divided by b whole power n, means the power comes as a whole. So let's take an example, like if you have 2 to the power 3 divided by 2 to the power, sorry, we should be having different bases, so 3 to the power 3, same powers, different bases, so you can write it as 2 over 3 whole power 3. The same applies with the variables also, and in the same way it is also true in the opposite way. If you are being given a divided by b with a whole power n, then this power will be distributed on your both the numbers or variables, like a to the power n divided by b to the power n. I hope you understand this. Okay, this is true in both ways. Like this. Okay, now let's move on to our next law, and the next law of index is, if you have anything to the power 0, okay, let's say your base is any number, anything to the power 0 is always 1. Even x to the power 0 is 1. Even if you have 2000 or 200,000 to the power 0, if the power is 0, that gives you equals to 1. So anything to the power 0 is equals to 1. Now let's talk about one more thing. Okay, now the next two laws are actually about the negative powers. If you have negative power, that means that you have to do the reciprocal. When you do the reciprocal, your sign changes to positive. Okay, whenever you have a power negative, you reciprocal or flip your fraction, you get positive power. So what was it initially? It was a over 1. So the base gets flipped, the fraction got flipped. Okay, it becomes 1 over a to the power m. For example, if you have 2 to the power minus 1, that means 1 over 2 to the power positive 1. Or if you have x to the power minus 2, that means 1 over x square. Okay, so we always reciprocal it. So there is another version for this, and that is, for example, if you have a whole fraction, instead of having a denominator 1, you are having a proper fraction a over b with some negative power. So always to change it to a positive power, we do the reciprocal or flip. Okay, there are few terms associated with it. You do the reciprocal, you flip the fraction, means numerator becomes denominator and denominator becomes numerator. What is numerator and what is denominator? numerator is the upper part of the fraction. Okay, some people don't know about this numerator and denominator, so that is why I am explaining this. I have seen my students don't know mostly about it. Okay, that is why I am explaining. So in a fraction, the upper part is numerator, the lower part is denominator. So n refers to numerator and d refers to denominator. So this is it. So what becomes in the reciprocal or flipping part? Your numerator becomes denominator and denominator becomes numerator. So if you have a over b to the power minus 1 minus m, then it will become, if you flip the fraction, it will become b over a to the power positive m. Okay, so let's take an example. For example, if you have 2 over 3 to the power minus 1, that will become actually 3 over 2 to the power 1. Okay, that's about negative power. Now comes the fractional power. 1 over n represents a fractional power. So if you are being given a to the power 1 over n, what does it represents actually is nth root of a. For example, if you have, all of you have gone through this thing, that is that square root of 2 or square root of any number. What it is actually, it's the second root, means the power is 1 over 2. In the same way, we don't write a 2 for a square root, we just write this this thing, okay, this radical that represents the square root. Now what is, if the power is 1 over 3, if the power is 1 over 3, we call it to be cube root. For all the other rest of the roots, we just write it to be as, whatever the power is, we write just like in a superscript, we just write the small number, whether it be 4, 5, 6, and we call it to be 5th root, 6th root, and so on. So let me say this, that this is a nth root. So what is nth root means? Nth root means that your power is 1 over n. Okay, this is all about the root. So fractional power is actually the root. Now if you have been given, now there is one more variation to this fractional power, and that is you could have a complete fraction m over n form. So what does it mean? It means actually that you can by using this law, the two powers are multiplied when it is when you have m times n. The opposite of it is also true, that if you have m times n, then you can write it separately, m to the power n. Now look at this. Sorry, not this one. That means that you can split it as a to the power m multiplied by 1 over n. It is the same way, like if it is m over n, any fraction like 2 over 3, you can write it to be by splitting it as 2 times 1 over 3. Why we are doing this? To keep the fractional part separated from the number part. So if you can do this, then you can write it as, in two ways you can write this, either m a to the power m and represent nth root as outside, or you can write it as a to the power a nth root whole power m. We are doing, why I am referring to this, because we can write, if when we have two powers we multiply them, and if we have multiplication of two powers, we can write them as one whole power of the other power. So you can write it in both ways, that nth root of a to the power m, or nth root of a whole power m. I will show its example to you. For example, if we have 2 to the power 3 over 2, you can write it as 2, 3 multiplied by 1 over 2. Now you can either write it as 2 cube under the root or square root of 2 whole power 3. I hope you get it. You can either take this as a whole power or take this as a whole power, because these both are multiplied. So this is all about your second last law of index. The last law of index is, if you have 1 with any power n, 1 to any power will give you just 1. Okay, any power of 1 will not change 1, it will still stay the same as 1. So let's just see this. Okay, that's all about your law of indices. These are all the law of indices that you may come across in your solving of indices. I will be sharing with you a separate video for the topical questions, recent topical questions for this particular topic. Yes, we come across most of the times one question in your papers is about these indices or surds. So we will be covering all these topics. Along with that, we will be sharing with you some solved topicals, recent topical questions. So I guess so that's all about this first topic. I'll be sharing another video for the rest of the topics. Thank you, and please write us in the comment box about this new series. Thank you. Allah Hafiz.